ओके, हामी यसैमा थियौं। यही कुरा हामीले डिस्कसन गर्दै थियौं हैन?
हजुर सर।
ल यहाँसम्म हामीले डिस्कसन गरिसकेका थियौं म्याग्नेटिक प्रपर्टिजको बारेमा हामी डिस्कसन गर्दै थियौं। अब यसको कन्क्लुजन पार्ट के थियो त भन्दाखेरि इन टोटल म्याग्नेटिक मोमेन्टको यो प्याराम्याग्नेटिजम अथवा म्याग्नेटिक मोमेन्टको भ्यालु केबाट अब्टेन हुन्छ त भन्दा स्पिनिङ एन्ड अर्बिटल कन्ट्रिब्युसन अफ इलेक्ट्रोनबाट अब्टेन हुन्छ। द म्याग्नेटिजम फर्स्ट इन्क्रिजेस, यो बारेमा हामीले डिस्कसन गरिसक्यौं। एन्ड अनपेयर्ड इलेक्ट्रोनको नम्बर इन्क्रिज हुँदै जाँदाखेरिमा म्याग्नेटिक मोमेन्टको भ्यालु पनि इन्क्रिज हुँदै जान्छ। एज द नम्बर अफ अनपेयर्ड इलेक्ट्रोन गोज अन इन्क्रिजिङ, the value of magnetic moment also gets increased, so that on d block element first the value of magnetic moment gets increased, becomes maximum, and then goes on decreasing. Since the number of unpaired electrons at first increases and then decreases for the same oxidation number for transition elements, that is paramagnetism first increases in any transition element series and then decreases, so that the maximum paramagnetism is observed around the middle of the series. Simple meaning of this is, as the number of unpaired electron increases, paramagnetic character goes on increasing. Paramagnetism gets increased as the number of unpaired electron gets increased, and this is expressed in Bohr magneton unit. And the relation between magnetic moment and the number of unpaired electrons is given by spin only formula. First we are going to discuss spin only formula, and then later on we will go to discuss both spinning and orbital contribution of electron. And the spin only formula of magnetic moment is magnetic moment mu or mu s. Mu s means this is spin only formula. So we can write here mu s. It is equal to square root of n plus 2 bm, where n is the number of unpaired electrons. N is the number of unpaired electrons. As the value of n increases, the value of magnetic moment also gets increased, so that greater paramagnetic character will be observed. Greater paramagnetic character will be observed. As the number of unpaired electrons gets increased, the value of magnetic moment also gets increased, so that the greater paramagnetic character will be obtained, or higher will be the paramagnetic character. And here bm is the unit of magnetic moment. Its full form is Bohr magneton, or unit of magnetic moment. And one Bohr magneton will be equal to Eh divided by 4 pi mc. 1 bm, 1 Bohr magneton, the numerical value of 1 Bohr magneton will be equal to Eh by 4 pi mc. E means electronic charge, H means Planck's constant, divided by 4 pi. M means mass of electron, C is velocity of light, or you can use speed of light as well. Velocity of light.
सर हजुरले अहिले कुन स्क्रिन शेयर गर्नुभएको छ? हाम्रोमा त पावर पोइन्टको मात्रै आइरहेछ त।
हजुर
हजुरले के अर्कै स्क्रिनमा लेख्नु केही लेख्नु भएको छ र? यहाँ त पावर पोइन्टको मात्रै आइरहेछ त, मेरोमा मात्रै हो कि के हो?
लेखिरहेको छु मैले।
मेरो पनि त्यो देखिएन सर।
लेखेको केही आकै छैन के? सायद त्यो शेयर भएन होला सबै।
होला अब दुई जना कहाँ भएछ त?
अब आयो?
छैन सर, फुल स्क्रिन शेयर गर्नु न अनि मिल्छ कि? सर्ट एन्ड विन्डो मात्रै भएर होला जस्तो भयो।
आछैन र अब?
मेरोमा चाहिँ आएको छैन है।
छैन सर।
आयो
छैन सर, छैन।
के हुन्छ बेला बेलामा? अब छ
सर।
ल म यति कुरा डिस्कसन गरिसकेको। number of unpaired electron gets increased, then the value of magnetic moment also gets increased, so that the paramagnetic character will be greater, or greater will be the paramagnetic character. And this is the formula, spin only formula. Mu or mu s equal to square root of n plus 2 bm. It is only spin only formula. You have to calculate the value of magnetic moment for the given species. For example, in Fe2 plus, what is the value of magnetic moment? Calculate the value of magnetic moment in Fe2 plus. Can you calculate? Calculate the value of magnetic moment in Fe2 plus. What will be the value of magnetic moment in Fe2 plus? For this, for Fe2 plus, if you want to calculate the value of magnetic moment for Fe2 plus, first of all, you have to write its electronic configuration. Electronic configuration of Fe2 plus will be argon. Electronic configuration of Fe2 plus will be argon. Then it is atomic number of iron is 26, so it has 3d6 4s0 electronic configuration. Write only outer electronic configuration. Its only outer electronic configuration will be, put it in box notation, 1 2 3 4 5. This one is 3d. 3d subcell consists 6 electrons. First electron goes up singly. First electron gets singly filled, then after pairing takes place. So here, number of unpaired electrons equal to number of unpaired electrons, in this case, number of unpaired electrons in this case, which can be written as n will be equal to, this electron is paired, these two electrons are paired, and we have 1 2 3 4. It has 4 unpaired electrons. So number of unpaired electron in this case is 4. So since we have spin only formula of magnetic moment, mu or mu s, since we are dealing only about spinning contribution of electron, mu or mu s is equal to, we have known formula, square root of n plus 2 bm. n plus 2 bm. Bm means Bohr magneton. Put the values of n here. Number of unpaired electron here is 4. So the value of n is 4. And n plus 2 means 4 plus 2. 4 plus 2 square root. It is Bm. Bohr magneton. Bm. Then you can solve it. 4 plus 2 6. 6 for 24. Square root 24. Bohr magneton. Bohr magneton. From this calculation, what we can conclude is, since Fe2 plus consists 4 unpaired electrons, it is paramagnetic in character. Fe2 plus, since consists 4 unpaired electrons, it is paramagnetic character. Paramagnetic. It is paramagnetic substance, or it shows paramagnetic character. And the value of magnetic moment for this Fe2 plus is obtained to be, mu will be equal to square root of 24 bm. Square root of 24 bm. This is the value of magnetic moment for Fe2 plus. In this way, you can find the value of magnetic moment for the given species as well. First, write the electronic configuration of that given ions. If the compound is given, suppose for example copper sulfate is given. If the compound copper sulfate is given, in that condition, first find the oxidation number of central element here. Copper is the central element, so you can find the oxidation number of copper here. X, sulfate is radical, charge is -2. As a whole, the molecule is neutral, equal to 0. So you can calculate X equal to +2. First find the oxidation number of the central element, central metal atom here, and then after Cu+2, write the electronic configuration of Cu+2 and do in similar manner. you can solve in this similar manner as well. Means once you know the electronic configuration of the given ion or species, you can determine the number of unpaired electrons present in that ion or species. If you can determine the number of unpaired electron, then you can determine the value of magnetic moment mu. Magnetic moment mu को value पनि हामीले easily determine गर्न सकिन्छ. Now let's go to spinning and orbital contribution of electron. The magnetic field produced by unpaired electrons is partly due to their spin and partly due to their orbital contribution or orbital motion of the electron. Means in total, actual value of magnetic moment is obtained by spinning and orbital contribution of electron. If we consider both contribution of the electron, then the value of magnetic moment can be given by the formula mu is equal to mu s plus L. Mu is equal to mu s plus L. It is equal to square root of 4s s plus 1 plus L plus 1. This is the actual formula or total formula for the value of magnetic moment if we consider spinning and orbital contribution of the electron. Here, this S is sum of spin quantum number. S means sum of spin quantum number. L means sum of orbital angular momentum quantum number. Sum of spin quantum number means S is the total sum of the spin quantum number, which is equal to n by 2. N means number of unpaired electron. What does it mean is that let us consider we have 2 electrons in this subcell. 2 electrons in this subcell. Both are in a clockwise direction. So it has plus half spin. It also has plus half spin. So sum of spin quantum number will be equal to plus half plus again plus half. On solving you will get 1. Sum of spin quantum number for the 2 electrons in this subcell will be equal to 1. Without doing this, you can easily write n by 2, where n is the number of unpaired electrons. So in another way, here's yes, it will be equal to, there are 2 unpaired electrons in this case, 2 unpaired electrons. For 2 unpaired electrons, the value of n is 2 over 2, so it will be equal to 1. You can use any one of these 2 formula to determine the total spin quantum numbers, sum total of the spin quantum numbers. Either it is equal to n by 2, or you can add the values of spin quantum number so that you can find the total of the spin quantum numbers. Similarly, L is the resultant of the orbital angular momentum quantum number of all the electrons in the molecule. You can add in the same manner. If L equal to 0, then if small l is equal to 0, then capital L will also be 0. If small l will be equal to -1, 0, plus 1, -1, 0, plus 1, you can add these parameter as well. If you have only 2 electrons, then it has -1 and +1 -1 and 0 contribution, so that you can determine the value of L. By adding the small l, you can determine the value of capital L as well. Now, in total, the magnetic moment is obtained from spin and orbital contribution of the electron. But the experimental value of magnetic moment, which I have told you in previous class as well, this mu can be determined experimentally. The experimental value of magnetic moment and the value of magnetic moment determined by spin contribution of electron is approximately same for most of the compounds of 3D transition element. So that what we can conclude is this orbital contribution is quenched or suppressed. This value will be 0. You do not have to consider this value, so you can use only spin only formula for the compounds of dipole 3D elements. But it has been found that in a number of compounds, including first row of transition elements, the orbital contribution is quenched or suppressed by the electric fields of the surrounding atoms. That is, the value of L will be equal to 0. As the slight approximation, the orbital contribution can be ignored. It can be ignored since its value is approximately equal to 0. And the observed magnetic moment is considered to arise only from the unpaired spins or unpaired electrons. So that the spin only magnetic moment mu s can be written as mu will be equal to mu s. It is equal to square root of 4s s plus 1. We are considering spin only formula now. If we replace the term s by n by 2, if you replace the term S by N by 2, then you will have the formula this one, mu or mu S equal to square root of N plus 2 Bm. This formula is obtained by deriving this formula by replacing capital S by small n. S equals to N by 2, here is also N by 2. If you solve this, you can get this formula. Means spin only contribution of electron is sufficient to explain the magnetic moment of the compounds of 3D elements. This is all about magnetic properties of transition element. Any confusion?
सर यो भन्दा अगाडिको स्टेपमा थियो नि फर्मुला यो म्याग्नेटिक मोमेन्टको त्यसको त्यो
ए फर्मुला त हो नि
एल्ट्रोनको बारेमा
कुन फर्मुला
यो 4s s हैन त्यो l पनि भयो l ब्र्याकेट भित्र l + 1 पनि इन्क्लुड गरेको थियौ नि
यो वाला अहिले स्क्रिनमा हेर न यो वाला भने हैन
त्यही भनेको
के त यसमा
त्यो एल्ट्रोनको बारेमा फेरि भन्दैन न त्यो रिजल्टेन्ट के लेख्नु भएको यो तल
ल resultant of the orbital angular momentum quantum number, resultant of the orbital angular momentum quantum number or azimuthal quantum number. जस्तो मसँग d सबसेल छ भने d सबसेल छ भने d को लागि l को भ्यालु कति कति हुन्छ d सबसेलमा 5 वटा orbital हो d को लागि l को भ्यालु कति हुन्छ 2 हुन्छ सो -2 अथवा +2 बाट स्टार्ट गरौँ +2 +1 0 -1 -2 हुन्छ नि यो ठीक छ
सर
अब यदि मसँग दुईटा मात्रै इलेक्ट्रोन छ भने 1 2 3 4 5 भयो दुईटा मात्रै इलेक्ट्रोन छ भने यो एउटा इलेक्ट्रोन छ भने यो जोड्दिने के 2 + 1 भयो तीनटा इलेक्ट्रोन छ भने यो तीनटा जोड्ने चारवटा इलेक्ट्रोन छ भने यो पनि जोड्दिने पाँचवटा छ भने यो पनि जोड्दिने भन्न खोजेको भयो तर यो हामीले कन्सिडर गर्नु पर्दैन हामीलाई चाहिँ स्पिन वाली फर्मुलाले मात्रै काम गर्छ 45D को लागि मात्रै यो चाहिन्छ अहिले चाहिँ हामीलाई यो चाहिदैन हामीले पढ्नु पर्ने चाहिँ यति मात्रै हो
सर त्यो माइनसको चाहिँ घट्छ कि नै भन्नु भयो
जोड्ने त्यति जोड्दिने भएर जस्तो हाम्रो स्पिन क्वान्टम नम्बर सबै जोड्दिने के स्पिन क्वान्टम नम्बरमा जस्तो पेयर्ड इलेक्ट्रोन छ भने यसको सम अफ स्पिन क्वान्टम नम्बर कति हुनु पर्यो त +½ +- जोड्दिने के सिधै +½ -½ कति हुन्छ 0 हुन्छ l मा पनि त्यसरी नै जोड्ने s मा पनि त्यसरी नै जोड्ने त्यो प्लस माइनसले पनि कन्सिडर गर्नु पर्यो ल अब यो क्वेशन गर्न सकिन्छ कि सकिन्न एकचोटी हेरौँ त क्यान यु सल्भ दिस क्वेशन दिस टु क्वेशन्स सकिन्छन् म अगाडि बढ्छु यो क्वेशन सल्भ गर्न सकिन्छ कि सकिन्न होला खोइ आवाज आएन त
सकिन्छ सर सकिन्छ
त्यही अनपेयर इलेक्ट्रोनको भ्यालु निकालेर गर्न सकिन्छ होला सर
अहिले मैले गर्दै नि एउटा Fe2+ मा Fe2+ मैले भर्खर गर्दै हैन एउटा कहाँ गयो यो वाला हो यसरी नै गर्ने पहिला सबैको लागि यति गर्ने पहिला सबैको लागि यति गर्न सकिन्छ हैन आयनको आयन दिएको छ आयनको कन्फिगरेसन लेख्ने म्यु निकाल्ने अनि यहाँ Fe2+ इज प्याराम्याग्नेटिक अनि म्यु इज इक्वल टु यति भनेर लेख्ने अनि त्यस्तै गरी Fe2+ को लागि त गर्यो हामीले त्यस्तै गरी हामी के को लागि पनि गर्ने Mn2+ को लागि पनि गर्ने त्यसै गरी अनपेयर्ड इलेक्ट्रोन निकाल्ने म्यू को भ्यालु डिटरमाइन गर्ने, यसमा पनि अनपेयर्ड इलेक्ट्रोनको भ्यालु निकाल्ने म्यू को भ्यालु डिटरमाइन गर्ने, n निकाल्ने म्यू निकाल्ने, यसको लागि पनि n निकाल्ने म्यू निकाल्ने, यसको लागि पनि n निकाल्ने म्यू निकाल्ने। अनि सबैको लास्टमा डाया हो कि प्याराम्याग्नेटिक लेख्ने, यसको पनि डाया हो कि प्याराम्याग्नेटिक लेख्ने। राइट हियर वेदर इट इज डायम्याग्नेटिक और प्याराम्याग्नेटिक, यसको लागि पनि डाया हो कि प्यारा हो लेखिदिने। यति लेखिसकेपछि लास्टमा कन्क्लुजन एउटा पार्टमा के लेख्नु पर्यो त भन्दा हिन्ट्स, लास्टको कन्क्लुजन पार्ट है, अरु गर्न सकिन्छ होला। अब लास्टको कन्क्लुजन पार्टमा के गर्ने, फ्रम द अबव कन्क्लुजन, फ्रम द अबव डिस्कसन और फ्रम द अबव क्याल्कुलेसन Fe2 plus Mn2 plus and CO2 plus are paramagnetic. These three will be paramagnetic, while Zn2 plus will be diamagnetic. We can predict by determining the unpaired electron present in this space, in these species as well. Fe2 plus Mn2 plus and CO2 plus are paramagnetic, and their paramagnetic character decreases in the order. I think Mn2 plus will be more paramagnetic, then Fe2 plus, then CO2 plus, then CO2 plus. This is the paramagnetic character order. As the number of unpaired electron increases, paramagnetic character also increases. As the number of unpaired electron increases, paramagnetic character also increases. So Mn2 plus consists greater number of unpaired electrons, so it is highly paramagnetic, then Fe2 plus, then CO2 plus, while Zn2 plus is diamagnetic. यति लेखेपछि हाम्रो नम्बर आइहाल्छ। बुझियो नि तरिका हैन? तरिका मैले बताइदिएको।
सर यो डायम्याग्नेटिक को नेट म्याग्नेटिक मोमेन्ट 0 हुने भए सर यो हल्का रिपेल चाहिँ किन हुन्छ?
हजुर
सर यो डायम्याग्नेटिक को म्याग्नेटिक मोमेन्ट 0 भयो हैन, अनि यो म्याग्नेटिक फिल्डमा राखे चाहिँ हल्का रिपेल हुन्छ नि, मतलब अपोजिट डाइरेक्सनमा फोर्स लाग्छ नि, त्यो चाहिँ सर किन हुन्छ?
मतलब म्याग्नेटिक मोमेन्टको भ्यालु पो 0 आएको त, म्याग्नेटिक बिहेभियरै 0 हैन नि त। म्याग्नेटिक बिहेभियर त त्यसले एक्जिबिट गरिहाल्छ। म्याग्नेटिक फिल्डमा राख्दाखेरिमा त्यो म्याग्नेटिक फिल्डमा राख्दाखेरि स्लाइड रिपल्सन हुन्छ, म्याग्नेटिक बिहेभियर आयो। म्याग्नेटिक मोमेन्टको जुन भ्यालु डिटरमाइन गरिन्छ अनपेयर्ड इलेक्ट्रोनको बेसिसमा म्याग्नेटिक मोमेन्टको भ्यालु डिटरमाइन गर्ने हो, त्यसको भ्यालु चाहिँ 0 आएको।
त्यस्तै गरी सर यो अनि अनपेयर्ड इलेक्ट्रोन हेरेर चाहिँ हामीले प्याराम्याग्नेटिक क्यारेक्टर र डायम्याग्नेटिक क्यारेक्टर छुट्याउँछौँ नि, यो ट्रान्जिसन एलिमेन्ट बाहेक अरु एलिमेन्टहरुमा यो लागू हुन्छ कि नै त?
अरुमा नि एप्लाई गर्न पाइयो। अनपेयर्ड इलेक्ट्रोन छ भने त्यो चाहिँ प्याराम्याग्नेटिक हुन्छ, छैन भने डायम्याग्नेटिक हुन्छ। तर तिमीहरुले जस्तो CO2 मा पनि एप्लाई गर्न पाइयो, CO2 मा पनि एप्लाई गर्न पाइयो, O2 मा पनि एप्लाई गर्न पाइयो, तर यसमा चाहिँ MOT तिर जानु पर्यो के। यतिकै इलेक्ट्रोनिक कन्फिगरेसन लेख्न मिलेन नि मोलिकुलको लागि त?
मिलेन त्यो त मोलिकुलर।
अनि यो त मोलिकुलर बन्यो, मोलिकुलर अर्बिटल कन्फिगरेसन लेख्नु पर्यो। मोलिकुलर अर्बिटल कन्फिगरेसन थाहा होला पढाएको छ भने, सिग्मा 1s सिग्मा स्टार 1s यो राखेर यदि अनपेयर्ड इलेक्ट्रोन देखियो भने त्यो चाहिँ प्याराम्याग्नेटिक हुन्छ, अनपेयर्ड इलेक्ट्रोन देखिएन भने त्यो डायम्याग्नेटिक हुन्छ। सबैमा एप्लाई गर्न पाइहाल्छ। भयो?
हुन्छ।
ल अब यो नेक्स्ट CO फर्स्ट इज डायम्याग्नेटिक whereas CO सेकेन्ड इज प्याराम्याग्नेटिक, गिभ रिजन। यो पनि गर्न सकिहालिन्छ, सेम वेबाट एक्सप्लेनेसन गर्दा भइहाल्छ। केही छ यसमा अझै क्वेशन सोध्नु पर्ने भने भनिहालौँ। छैन? लेट्स गो टु एलोय फर्मेसन। यो त खासै केही गाह्रो छैन। एलोय फर्मेसन, transition metals can form alloys with one another or with atoms of other element as well. One transition element can form alloy with another transition element as well, or with other element as well. Means transition element can form alloys with other elements or with another element of another transition element as well. How alloys are formed? Alloy बनाउने कसरी भन्दा दुईटा मेटल लिए मैले, this one is A metal, this one is May metal, but these both are in molten condition, not in solid state, but both are in molten condition. And then means take molten metals into different vessel first, and if you mix these two molten metals in a single vessel, mix these two molten metals in the same vessel and cool for some time, allow to cool for some time, then after alloys will be formed. If the molten metals are mixed together and allowed to cool for some time, then their alloys are formed. And during alloy formation, lattice point of one element is replaced by atoms of another element. Atoms of another element. During alloy formation, lattice point of one element is replaced by atoms of another element due to their comparable size. Due to their comparable size. Since size is nearly same, they have comparable size. Due to comparable size, lattice point of one element is replaced by atoms of another element. That's why alloys are formed. What does it mean is, suppose we have iron. Suppose this one is iron. Constituent particles are assumed to be sphere or spherical particles. This is the lattice point of iron. This is the lattice point of iron. This is the lattice point of iron. During steel formation, lattice point of iron is replaced by atoms of manganese. Since iron and manganese, size of iron and manganese is comparable. There is no drastic change in size of iron and manganese. So that suppose this plus is the lattice point of iron. Somewhere this plus charge, or this iron is replaced by atoms of manganese. Suppose here comes manganese, so that alloys is formed. So that alloys is formed. Manganese, so that alloy is formed. This is alloy formation, process of alloy formation. While in interstitial compound formation, this interstitial site, the empty space in between this constituent particle, this interstitial site is occupied by the smaller size atoms. If the interstitial site is occupied by smaller sized atoms, in that condition, interstitial compounds will be formed, while if lattice point of one element is replaced by atoms of another element, in that condition alloy is formed. Alloy formation हुँदाखेरि एउटाको ल्याटिस पोइन्टलाई अर्को एलिमेन्टको एटमले रिप्लेस गर्छ भने इन्टरस्टिशियल कम्पाउन्ड फर्मेसन हुँदाखेरिमा बीचको जुन इन्टरस्टिशियल स्पेस हुन्छ, बीचमा जुन भ्याकेन्ट स्पेस हुन्छ, त्यसलाई चाहिँ अरु एलिमेन्टको अरु स्मलर साइज एटमले रिप्लेस गर्छ, त्यतिबेला चाहिँ इन्टरस्टिशियल कम्पाउन्ड फर्मेसन हुन्छ. लेट्स हैव अ लुक हियर. Alloy means homogeneous mixture of metal or metal with another element. This is called alloy, and it is usually composed of two or more metals. Transition metals mix freely with each other in the molten state, and on cooling or solution of different metal result in the alloy. First, molten metals are mixed together and then allowed to cool them. Then after, alloys are formed. For example, chromium dissolves in nickel to form chromium nickel alloy. Similarly, manganese dissolves in iron to form manganese steels, while brass is the alloy of copper and zinc, or zinc and copper. Brass is the alloy of zinc and copper, while bronze is the alloy of copper and tin. The alloy formation is explained on the basis of similar sizes of the atoms of these elements, which allow the atoms of one metal to take up the position in the crystal lattice of the other. Alloys are generally harder, high melting points, and are more resistant to corrosion than the individual metals, so that it is necessary to prepare alloys as well. For example, iron is highly corrosive. If you form alloy from steel from iron, then it is corrosion resistant to corrosion, so that alloys are necessary to prepare as well. This is all about alloy formation. यसमा खासै केही छैन. Alloy बन्छ, अरु एलिमेन्टसँग अथवा ट्रान्जिसन एलिमेन्टकै अर्को एलिमेन्टसँग भनेर भन्दाखेरि भइहाल्छ, गाह्रो छैन। अब जाउँ अर्कोमा, एप्लिकेसन अफ ट्रान्जिसन एलिमेन्ट्स, एप्लिकेसन अफ ट्रान्जिसन मेटल्स. This is actually your self-study part. This is actually your self-study part. You have to do it yourself. Some points are given here as well. I'm going to discuss only certain properties of transition element or certain application of transition element. You can search the engineering application of transition element. Engineering application of transition element or application of transition element in engineering point of view. You can search yourself. This one is self-study part. But some properties are mentioned here. The foremost application of transition element is in chemistry. They are used in as catalyst. Many transition elements and their compounds have catalytic properties or they are used in catalyst. हामीले धेरै catalyst को रूपमा त क्लास 11 मा 12 मा पनि पढिसकेका छौं. Some examples are finely divided iron. In Haber process, iron is used as catalyst. Haber process for the manufacture of ammonia, N2 plus 3H2 it gives 2NH3. Haber's process for manufacture of ammonia. In this case, iron is used as catalyst. Similarly, vanadium pentoxide or platinum acts as catalyst for the oxidation of SO2 to SO3 in contact process for the manufacture of sulfur. In contact process for the oxidation of SO2 to SO3, SO2 plus O2, 2SO2 plus O2, on reaction it gives 2SO3. Catalyst is required here as well. B2O5 or platinum is used as catalyst in contact process for the manufacture of sulfuric acid. Haber's process, contact process requires catalyst as well. Similarly, nickel powder is a good catalyst for hydrogenation of unsaturated organic compounds such as oil. If you want to convert alkynes to alkenes, which then to alkanes, you need catalyst. Here, nickel powder or platinum or palladium is used as catalyst for the hydrogenation reaction. Vanaspati oil can be converted into vanaspati ghee in presence of hydrogen by the use of catalyst, nickel or platinum catalyst. Means for hydrogenation reaction as well, transition metal elements can be used as catalyst or are used as catalyst. Similarly, Fenton's reagent. Fenton's reagent is ferrous sulfate and hydrogen peroxide, FeSO4 and H2O2, which is commonly called as Fenton's reagent, is used for the oxidation of alcohols to aldehydes. If stronger oxidizing agents, here if stronger oxidizing agents are used for the conversion of, for the oxidation of alcohols, then it gets first converted to aldehydes and then to carboxylic acids. To stop the oxidation process up to aldehydes, here we have to use Fenton's reagent, or you can use PCC, pyridinium chlorochromate. It stops the oxidation of alcohol to aldehydes. If strong oxidizing agents like KMNO4 or K2Cr2O7 are used, then alcohols are first gets oxidized to aldehydes, which on further oxidation undergoes, which on further oxidation gives carboxylic acid. So Fenton's reagent is also used for the oxidation of alcohols to aldehydes only. Similarly, Jaeger-Natta catalyst is used in the production of polyethylene. Very important catalyst, this one. Polyethylene. Polyethylene is a very essential part of our life as well. For this process, Jaeger-Natta catalyst is used as catalyst. MnO2 is used as catalyst to decompose KClO3 to give oxygen. You have read in class 11 as well. Similarly, iron and steels are important construction materials. You know it better. Alloys of transition metals with non-transition metals such as brass, Cu and Zn, bronze, Cu and Sn are also of considerable importance. KMNO4 is used as disinfectant oxidizing agent in volumetric reagent and is used for the estimation of ferrous salts. We will do this in lab as well. If our lab starts, then we will do this estimation of iron from more salt. We will do this one in the lab as well. These are the some representative application of transition metals. You can search other applications in engineering point of view as well. This is all about application of transition metals, some application of transition metals, and this is all about your D block elements. D block elements सकिएको छ. केही सेसन सोध्नु पर्ने? D block elements gets completed. I have completed D block elements. What about you भनेर साथीलाई छिटै सोध्नु होला.
सर यो कलर पढाइथ्यौँ नि हामीले अस्ति त्यो डी ब्लक एलिमेन्टको हैन त्यसमा सर त्यो कलर फर्मेसनमा T2G2 इजी सेट अफ अर्बिटल्समा ट्रान्जिसन भइसकेपछि त्यो ग्राउन्ड स्टेटमा फेरि फर्केर आउँछ होला नि त सर.
अब त्यो एब्जर्प्सन स्पेक्ट्रा र इमिसन स्पेक्ट्रा हुन्छ हैन. एब्जर्प्सन स्पेक्ट्राकै बारेमा एक्सप्लेन गर्दा हुन्छ, इमिसन स्पेक्ट्रा चाहिँदैन.
ए सर मैले भन्नु खोजेको त्यो फर्केर आउँदाखेरि चाहिँ फेरि त्यही कलर चाहिँ इमिट गर्छ कि गर्दैन भनेर खोजेको सर.
अनि त्यो चाहिँ अब जस्तो त्यो किन ट्रान्जिसन भयो भन्दाखेरि कम्प्लेक्स फर्मेसन गर्नको लागि ट्रान्जिसन भएर बस्यो नि त.
ए भनेपछि इमिट गर्दैन.
त्यो भएर त्यहाँ हामीले त्यो फेरि लोअर इनर्जी लेभलमा ब्याक भयो अनि त्यसले फेरि कलर इमिट गर्छ. त्यो देखिन्छ भन्दा पनि एब्जर्प्सन गर्दाखेरि त्यो इनर्जी डिफरेन्स त एउटै त भयो नि आखिर.
त्यही भयो.
जति इनर्जी एब्जर्ब गरेको छ त्यति इनर्जी नै रिलिज गर्ने भयो हैन.
हजुर हजुर.
भनेपछि त्यो त्यति इनर्जी एब्जर्ब गर्छ, रिमेनिङ कलर अफ लाइट ट्रान्समिटेड हुन्छ अनि त्यो ट्रान्समिटेड लाइटको कम्प्लिमेन्टरी कलर देखिन्छ भन्दा हुन्छ. अरु केही? छैन?
छैन सर.
ल त्यसो भए म यो टपिक 2-4 मिनेट मात्रै डिस्कसन गरेँ है त मैले यसलाई. के पढ्नुपर्छ मैले ओभरभ्यू मात्रै गर्दिन खोजेको आज किन ओभरभ्यू गर्दिन खोजेको त भन्दा यसो घरमा खोजिन्छ नि त यो पढ्नु पर्दो रहेछ भनेर यसो सर्च गर्दै गरौँ कुनै इन्ट्रेस्टिङ लाग्छ कि यसमा हेरौँ है त. कोअर्डिनेसन केमिस्ट्री और कम्प्लेक्स कम्पाउन्ड्स. Topic overview. At first, we will go to introduction of coordination chemistry. General introduction of coordination chemistry. What are complex compounds? What are double salt or lattice compounds? What is coordination compound or complex salt? Similarly, we will deal about terms in coordination complexes. Here, we use the term ligand, its classification. Homoleptic ligand, heteroleptic, homoleptic complex compounds, heteroleptic complex compounds, ambidentral ligands, chelating ligands. What is coordination number? What is coordination sphere? What is ionization sphere? These terms will be discussed in these terms used in coordination complexes. Similarly, we will go to bonding in coordination complexes. First is Werner's coordination theory. First, the structure of complex compound is given by Werner's theory. So Alfred Werner, it is given by Alfred Werner. You are regarded as Nobel Prize for his work in this field. Werner's theory of coordination compounds. Who is the father of coordination chemistry? Alfred Werner is the father of coordination chemistry. Is an honor for his work in this field as well. Then after we'll go to Sedgwick's model and Sedgwick's effective atomic number rule, which can be abbreviated as EAN, effective atomic number rule, EAN rule, effective atomic number rule. And what is the application of effective atomic number rule? Why we have to calculate the effective atomic number rule? What is the application? What is the importance of EAN rule? We will go on this. Similarly, nomenclature of coordination compounds. We have to nomenclate the coordination or complex compounds. We have read nomenclature of organic compounds in class 11, but here we have to discuss the nomenclature of the coordination compounds. Balance bond theory for complexes. Balance bond theory you have read in class 12 as well. This is your self-study part. This one is self-study. You have to read the postulates of balance bond theory for complex compounds. I expect you will know the postulates of balance bond theory in next class. Not in next class, after 2 or 3 classes. Postulates of balance bond theory for complex compound. This is the self-study part. You have to read this. After knowing the postulates of balance bond theory, we will go to application of balance bond theory. We will go to different types of hybridization involved. sp3 hybridization, dsp2 hybridization, sp3d2 hybridization, sp3d2 hybridization, and then d2sp3 hybridization. These are the different hybridizations that will be dealt in this balance bond theory or in application part of balance bond theory. What are the geometry of this complex compound? If there is sp3 hybridization, then you will have tetrahedral geometry, tetrahedral structure, dsp2 square planar, sp3d2 octahedral. Similarly, d2sp3, if there is d2sp3 hybridization, then you will have octahedral structure as well. This is the application part of this coordination theory. Sorry, balance bond theory. Thereafter, we will go to limitation of balance bond theory, some limitation of balance bond theory. And at last, application of coordination complexes. We will go to application of coordination complexes. This is also a self-study part. Application part is self-study. You can do it yourself. This is the topic overview for this complex compound. अब यहाँ हामीले क्लास 12 मा तिमीहरुले डबल सल्ट कम्प्लेक्स सल्ट टाइप्स अफ सल्ट पढाएको थियो कि थिएन टाइप्स अफ सल्ट पढेको हो कि हैन एकचोटी यसलाई रिकल गरेर आउँ टाइप्स अफ सल्टमा नर्मल सल्ट पढे होला एसिड सल्ट बेस सल्ट डबल सल्ट मिक्स सल्ट कम्प्लेक्स सल्ट यो पढेको होला सबैले normal salt, acid salt, base salt, double salt, mixed salt, and then complex salt. यसरी सर यो के रहेछ हेरौं हैन अनि मैले यहाँ डिस्कसन गर्ने चाहिँ डबल सल्ट र कम्प्लेक्स सल्ट कसरी आइडेन्टिफाई गर्न सकिन्छ त्यो पनि खोजेर आउँ ल म नेक्स्ट क्लासमा स्टार्ट गरौँला यो टपिक आज जस्ट ओभरभ्यू मात्रै मैले किन भनेको भन्दा यसो अल्छी लागेको बेलामा यो हेर्न सकिन्छ भनेर नेक्स्ट क्लासमा हामी यही जनरल इन्ट्रोडक्सनबाट डबल सल्ट र कम्प्लेक्स सल्टबाट डिस्कसन स्टार्ट गर्छौं त्यो भनेको के हो एकचोटी खोजेर आउनु पर्यो अर्को दिन हामी यो टपिक विधिवत स्टार्ट गरौँला है त
सर नोट्स सर राखिदिनु होला है
नोट्स अस्ति मैले राखिन है
नै छैन सर अपलोड गरेको छैन
ल अहिले म एकछिनमा राखिदिन्छु है त अहिले म राखिदिहालेँ फेरि बिर्सिँदो रहेछ कि